In this video, we're going to talk about 8.1 Objective 5, where we use sampling distributions to find probabilities. Let's go ahead and take a look at our first problem. Assume that newborn females have birth weights with a mean of 3,023 grams and a standard deviation of 696 grams. A random sample of 100 newborn females is obtained, and they have a mean birth weight of 2,950 grams. What is the probability of randomly selecting another 100 newborn females and getting a mean birth weight that is 2,950 grams or lower? And does it seem like a sample mean of 2,950 grams is unusual? So let's go ahead and show you how to do this with technology. We're going to go into our second distribution menu, and we're going to use normal CDF. And we're going to, we're doing lower than, so I'm going to use this number to represent negative infinity. I'm going to use my Z calculation here of X bar is 2950 minus my mu of 3023 divided by sigma was 696 divided by the square root of n was 100. Close parentheses for the square root, close parentheses for the denominator. That's a z value, so I'm going to let mu be 0 and my standard deviation be 1. And this is going to be 0.1471. Since the sample mean lies less than 2 standard deviations away from the mean, let me prove that to you. Let me get that z value for you of 2950 minus 3023 divided by 696 divided by the square root of 100. That's between -2 and 2, so it's less than 2 standard deviations away from the mean. Getting a mean birth weight that is 2950 grams is not unusual. And question 2, assume that 10% of adults are left-handed. If 200 adults are randomly selected, find the probability that 18 or fewer of them are left-handed, and does the result of 18 left-handed adults appear to be unusually low? There are a couple of different ways to do this problem with different distributions. We're going to stick with the normal distribution and say that mu is equal to NP and sigma is equal to the square root of NPQ. And this is approximately normal because this is so large. And we're not going to worry about doing any correction factor or anything like that right now. We're just going to come in here and say second distribution, normal CDF. And again, we want fewer than 18, so we're going to let that go to negative infinity. And this is going to be 18 minus the n of 200 times the p of 0.1, that's 20, divided by the square root of n times p times q. Close that parenthesis. That square root, it's in the denominator. These are z values, so we'll leave that 0 and 1. We're going to get 0.3187. And let's do this 18 minus 20 divided by the square root of 20 times 0.9. So the z value is negative 0.15, which definitely is less than 2 standard deviations away from the mean. So the result of 18 left-handed adults does not appear to be unusually low. All right, that's it for this video. We'll come back next time and we'll talk about 8.2 Objective 1. See you for the next video.